Hello, science family. We are here talking about double replacement reactions. And if we think about it, a double replacement reaction means that two different compounds meet up. Now, if the situation is right, what can happen is that the cations can swap. And if they do, a new compound is formed for each. So B and X are now together, and A and Y are now together. So they just traded places. If that happens, that's called a double replacement. But we have to figure out if this reaction will actually happen. To do that, you have to check the two products to see if either of them will become a solid. If it becomes a solid, then we know the reaction takes place. If they end up both being aqueous, though, instead, then we know that there's going to be no reaction. So before we actually do a double replacement reaction, we take a look and see what the products would be, and then we're going to use our solubility chart here to actually figure that out. So if you look at the steps, first you're going to predict the products, predict exactly what's going to be formed. Then you're going to label them as either solid or aqueous. Then you'll actually finish the word equation and balance it. So there's a few steps in double replacement. But once we work through it, I think the examples will help you understand it fully. If we take a look at number 1, it says lead 2 nitrate is going to react with potassium iodide. So the first thing we're going to do, since it's a double replacement, is we're going to swap the places. So we're going to now have potassium, but potassium is no longer going to be with iodide, it's going to be with nitrate. So potassium nitrate potentially will form, and now lead 2 will be with iodide. So we'll call it lead 2 iodide. So that's first the word equation, but that's not enough. Next we have to figure out if either of these will become solid or will they be aqueous. So to do that, we're going to need to use our solubility chart. If I look, potassium is right there and nitrate is right there. So if I look across, potassium and nitrate, on the chart it has an S. S says it's soluble, which means it's aqueous. So potassium nitrate is going to be aqueous when they combine. All right, so that's nothing new. We wouldn't see anything new when these two aqueous dissolved salts would be mixed together. Let's look at lead 2 iodide. So here's lead 2 and here's iodide. Let's put them together and see what they become. Lead 2 and iodide come together, it forms an I according to the chart. I stands for solid. So this is going to create a solid. So since a new solid would be created, that's awesome. That means there's going to be a reaction. So what does that mean is next? We need to start writing out our equations. So we're going to start with lead 2 nitrate. Before we make the equation, I'm just going to look at their charges so I know how to put them together. So lead is 2 plus, nitrate's minus 1. Let's look at next potassium iodide. If I look on my ion sheet, potassium's plus 1, iodide is minus 1. If you're thinking, where are you getting these charges from? Remember, they're right on your solubility chart. They're right there. Up next then is the potassium nitrate. All right, potassium, before it forms a compound, is K plus 1. Nitrate is a negative 1. And then last but not least is lead 2 iodide. Pb with a 2 plus charge, and iodide has a minus 1. Now this isn't my answer, but this is all of my work so that I can write the compounds out properly. So let me do that. If the lead's 2 plus and nitrate's minus 1, I'm going to need 2 nitrates for every lead, okay? So I'm gonna say PbNO32 aqueous, right? That's what it says right here, it's aqueous, plus K plus 1 and I minus 1. So potassium iodide come together, just Ki. Those are both aqueous, it says so right here. Next, I'm going to look at potassium and nitrate. Potassium's plus 1, nitrate's minus 1, so they're just going to come together is KNO3. We figured out from the chart that means it's aqueous. And then last but not least is lead iodide, lead 2 iodide. Lead is 2 plus, iodide's minus 1. So you're going to need 2 iodides for every 1 lead. And remember, that is going to be solid. That determined that there was a reaction. All right, now that we have that, we need to balance this equation to make sure that it's a properly written chemical equation. All right, got 1 potassium on each side. I've got 2 nitrates over here, only 1 nitrate over here. So it looks like I'm going to need to put a 2 there. If I put a 2 there, there's now 2 potassiums. So I'll have to put a 2 here. But that'll make 2 iodides, which I already have, and 1 lead on each side. I think I ended up balancing it out. 1, 2, 2, 1. Again, notice I went through that a lot quicker than we used to, but that's because you're expected to know how to balance equations, and you're also expected to know how to write ionic compounds. If you can't get that far, that's okay. You need to go back and you need to get help on balancing equations or writing ionic compounds. Otherwise, we took the names, turned them into ionic compounds, wrote them out, whether they're aqueous or solid, and then from there balanced it, and you have your whole proper double replacement reaction. And there you go. That's example number 1. Looking at question number 2, we have sodium carbonate trying to react with calcium chloride. If those are going to go through a double replacement reaction, calcium and sodium are going to switch spots. So now instead of sodium carbonate, you're going to have calcium carbonate. Now I don't know if that's going to be a solid or aqueous yet, but I'll figure that out from my chart once I'm ready. But the other thing that's going to benefit now and create is sodium and chloride are going to come together. So sodium and chloride. All right, now that I have those, let's take a look and see from the chart if either one is going to make a solid compound. So I've got calcium coming together with carbonate. When those come together, it looks like the letter I, and I stands for insoluble, which means it won't dissolve, which means it'll form a solid. If I look at sodium chloride, sodium's down here, chloride's just 1 over. Go ahead and work our way down. That's an S. S stands for soluble, which means aqueous. So sodium chloride will be aqueous. But regardless, since calcium carbonate is solid, this reaction is actually going to take place. So now we can move forward and start writing a chemical equation. So the first thing I like to do is kind of work out what my charges are going to be. So sodium carbonate, sodium has a +1 charge according to the chart, and carbonate, CO3, with a -2 charge. Okay. Next up is calcium chloride. Calcium has a 2+ charge according to the chart. Chloride has a -1 charge. Up next then is going to be calcium carbonate. And now I know all my charges from the reactant side. Carbonate is CO3, 2-. And the last thing is sodium chloride. Sodium had a +1 charge, chloride had a -1 charge. Now that I have all my charges, I can use that to write out my proper equations. So carbonate's -2, so I'm going to need 2 sodiums for every carbonate. And we know that that is aqueous according to our word equation. Next up is calcium chloride. +2, so I'm going to need 2 chlorines to cancel that out. So CaCl2, and that is aqueous as well. Next up is then calcium carbonate. +2 and -2 means they cancel out. So that'll be that. And last but not least, sodium chloride. +1 -1 means NaCl. Let's not forget, easy to forget, I almost did. Calcium carbonate is solid. Sodium chloride is aqueous. Now that we have that, we can balance these out. If you take a look, I've got 2 chlorines on the reactant side, so I'm going to put a 2 there to get 2 chlorines. That'll give me 2 sodiums, which I already have over here, and I think everything balances out. It becomes 1, 1, 1, 2. All right, so those are the first 2 examples of the double replacement reaction. Let's keep working and do some more. Looking at question number 3, aluminum may potentially swap with silver. So if that's the case, silver is now going to be with iodide, and then aluminum is now going to be with nitrate. So before we can write out this official chemical equation, we want to make sure that silver iodide or aluminum nitrate is actually going to form a solid. So let's take a look. Silver is over here, iodide's over here. Let's trace this out. Silver and iodide, that's an I. I stands for solid. So it looks like silver iodide is going to become the solid. Next up is aluminum nitrate. We've got aluminum right there, nitrate right there. That looks like that's going to be soluble. So that's going to be aqueous. All right, now that we have that, we know we can start writing out our entire equation. But I'm going to start with just my notes, kind of looking into what are all the charges. And the nice thing is everything is right here on my chart. So aluminum is a +3 charge. Iodide is a -1. What else do we have? Silver nitrate. Silver is Ag with a +1 charge. And nitrate, NO3, has a -1 charge. Okay. Next up is silver iodide. Silver is +1. Iodide is -1. And then aluminum nitrate. Aluminum is 3+ and nitrate is -1. So the reason I write out all of those charges is just to help me so I know how to write my compounds, my chemical equation. So if there's aluminum has a 3+ and iodide has a -1, I'm going to need 3 of those iodides for every 1 aluminum to balance out. Don't forget too that this is going to be aqueous. Next up is silver nitrate. Silver nitrate is +1 -1, so that's going to cancel out 1 to 1, and that is aqueous as well. Next up then is silver and iodide +1 -1, so that's just going to be AgI. Don't forget, this is the winner right here. This is the solid that comes out, so we have to label that. And last is aluminum nitrate. Aluminum is 3+, so that means since nitrate's -1, we're going to need 3 of those to balance out, and that's going to be aqueous. Sweet. Now that I have that, all I have to do is worry about balancing. Yikes. Let's see here. I've got 3 nitrates here, so I'm going to need a 3 in front of that silver nitrate. But now that makes 3 silvers, 3 Ags, so I'm going to have to put a 3 there. But that's going to now make 3 iodides. Ooh, but I already have 3 iodides over here, so I'm good. I think that balances it. 1, 3, 3, 1. Great. There you have it for number 3. That was a double replacement reaction. Looking at question number 4, we've got a double replacement reaction. Copper 2 nitrate and sodium phosphate are 2 compounds, both aqueous, so they're swimming around in liquid water. So copper and sodium may swap. If that's the case, you're going to end up with sodium nitrate, and the other product that'll form would be copper 2 phosphate. So remember, before we're going to move any further though and start writing out our chemical equations, we have to really check if this is actually going to make a new compound, a new solid. So let's take a look. Sodium's right here, nitrate is up here. Let's take a look. Sodium and nitrate come up as S. Remember, S does not mean solid, it means soluble, which means aqueous. So this is going to be aqueous. And then let's look at copper 2 phosphate. Copper 2 is 2+, phosphate is 3-. And put those together, and that gives you the letter I. I stands for solid. So it looks like this is going to be our solid. So this is definitely going to be a reaction. Now that we have that, let's start breaking things down by their charges. And remember, all the charges are written right on that chart. So copper 2 nitrate, copper is going to be 2+, Nitrate, according to the chart, is NO3. That has a -1. Next up is sodium phosphate. According to the chart, sodium has a +1 charge, and phosphate, which is PO4, that whole thing chunked together has a -3 charge. Up next is sodium nitrate. Sodium, when it's forming a compound, has a +1 charge, and nitrate, we already know from the reactant side, has a -1 charge. And then last but not least is copper 2. It's copper 2, so it means it must be 2+ charge. And phosphate is PO4 with that 3-. Now that we have all of the charges, we can put these together and work them out into the chemical equations. Cleared up our space a little bit. Let's do this. Copper's 2+, nitrate's -1. So when those come together, you're going to need 2 of those nitrates in order to cancel out with the +2 copper. And we know from the word equation that's going to be aqueous. It's going to react with sodium phosphate. Sodium's +1 and phosphate's -3. So that means you're going to need 3 sodiums to balance out with one of those phosphates. All right, that's aqueous as well. Next up is sodium nitrate, +1 -1. Means that comes together 1 to 1, and that is aqueous as well. We already checked that, right? Aqueous right here. And then the last one is copper 2 phosphate. Now take a look at this. Copper is 2+, phosphate is 3-. So this one looks like I'm going to need 2 phosphates to make a -6. And 3 coppers to balance out that -6 with a +6. So this one is actually Cu3, and you need 2 phosphates. And remember that copper 2 phosphate is going to be the solid, so it's important to put that in there. Otherwise, if that didn't form a solid and it was aqueous, this wouldn't have been a reaction even. Now that we have that, let's just balance this out. It looks like we've got 3 coppers over here. I'm going to put a 3 here to see if that works. So let me put the 3 in. Now that's going to make 3 times 2 nitrates. That's going to give me 6 nitrates. So I'm going to put a 6 here to make 6 nitrates. But yikes, that makes 6 sodiums. I've got 3 sodiums here, so I will put a 2 there. 2 times 3 gives me 6 sodiums. And then that gives me 2 phosphates, which I have over here. So it looks like 3, 2, 6, 1 balances out that equation. There you go. That was number 4. But we're chugging along on our homework here.